Hello students, in the previous lecture we have taken a derivation regarding the parallel plate capacitor. So in this lecture we will take a derivation of a spherical capacitor. Also we will take a derivation of cylindrical capacitor. So cylindrical and spherical capacitor. So first we will take cylindrical capacitor. So for cylindrical capacitor, we have to consider a coaxial cable of a length L. So this is a coaxial cable of a length L. This coaxial cable is made up of two concentric conducting cylinders. So this is made up of two concentric cylinders. Inner cylinder as shown this, and this is a outer. Okay, the inner sphere is having a radius a and outer sphere is having a radius b. So this is a r is equal to a radius, and outer cylinder radius or sphere is a radius r is equal to b. Assume a charge density of a royal coulomb per meter is present on the inner conductor, then an equal and opposite charge minus royal will be present on the outer conductor. So if royal is present on the inner conductor, then minus royal is present on outer conductor. The total charge on the cable is Q is equal to rho L into L. Now, electric field intensity due to rho L is given by, so we have derived this expression in the first chapter, that is electric field intensity due to infinite line charge, which is given by E bar is equal to, or EL is equal to rho L upon 2 pi epsilon R AR cap. So this formula we have derived in the first chapter, and here we have to take that formula directly. This expression also can be written as E bar is equal to rho L upon 2 pi epsilon rho A rho cap. So rho and R are equal. So we can represent in this type or in the format of rho. So we will get this equation. Then next, so the potential difference between inner and outer conductor is given by integral minus b to a edl. So this is a formula from again first chapter. We have find out potential difference between 2 points. Then this is a formula. So put the values. Dl is equal to dr ar cap, and this differential length means differential length dr ar cap, and e is equal to rho L upon 2 pi epsilon r ar cap. So this differential length can be written as dr ar cap. So ar cap dot of ar cap becomes 1. Then take constant term rho L upon 2 pi epsilon r common. That is a means rho L upon 2 pi epsilon common here taken out, and we have to solve the integral b to a 1 upon r dr, which is equal to here integral dr upon r is a natural log of r, or integral dx upon x, same ln x, same formula applied here, and solve that integral, put the limits, will get this equation, that is minus L upon 2 pi epsilon ln a minus ln b. So if we multiply it by this negative sign to all these equation, then this equation becomes rho L upon 2 pi epsilon ln b minus ln a. That is, this negative term becomes positive and minus ln a as mentioned here. Okay, and such a type of expression here, this term can be written as rho L upon 2 pi epsilon ln b by a. But the capacitance C is given by C is equal to Q by I. So put all these values of this Q and V. So C is equal to rho L into L, rho L upon 2 pi epsilon ln B by A. Okay, so terms, those who are gets cancel those terms, that is rho L gets cancelled. Again, then 2 pi epsilon goes upper side, that is 2 pi epsilon L ln b by a. Okay, so this term is remaining. 2 pi epsilon L ln B by A. So capacitance for cylindrical capacitor is given by this equation. So derive expression for capacitance for cylindrical capacitor. Such type of derivation is asked. When you have to solve this derivation, you will get 6 to 7 marks. Okay. Next, spherical capacitor. Consider two concentric spherical conducting spheres of radius A and B as shown in figure. So this is a two conducting spherical capacitors. A having the radius R equal to A and outer having the radius R equal to B. The region between two spheres is filled with the dielectric having permittivity epsilon. So dielectricity, that is a region between two spheres is filled with the dielectric having permittivity epsilon. Okay. Now the potential difference between two spheres is given by V is equal to minus of integral B to A EDL. That is the same formula. Then next, as we know that electric field intensity due to point charge is given by formula Q upon 4 pi epsilon r square AR cap. Again, this formula is from first chapter. We have taken a concept of electric field intensity. So electric field intensity due to point charge formula is like this. So here AR bar is the unit vector in the radial direction case. Therefore, differential length along r direction is given by dr AR cap. So put all these values in the equation, that is V is equal to minus of integral B to A Q upon 4 pi epsilon r square dr AR cap. Okay, and this is a AR cap, that is a both the term AR bar dot of AR bar is a 1. So you can rewrite this equation like this. Solve this equation means integral. Uh, take constant, that is q upon 4 pi epsilon is a constant taken out. Then we have to solve integral b to a 1 upon r square dr. So here 1 upon r square dr we have to solve the integral. So for solving such type of integral, this is a 1 upon r square. Okay, so you can rewrite this as a ऊपर जाके r रेश टू क्या हो जाएगा -2. So what is the integral of that r raised to -2? Okay, what is the integral of x square? X cube upon cube. So r raised to -2 plus 1 we will get minus of r raised to -1 is यहाँ पे -1 आ जाएगा ये यहाँ पे. So if we solve this integral, we'll get ये r जो है नीचे आने के बाद कैसा लिख सकते हैं, minus of 1 by r. Okay, so this is a value of 1 by r, minus of 1 by r, ये integral. Okay, so 1 upon r square can be written as r raised to -2, and if we solve the integral of r raised to -2, r raised to -2 plus 1 is upon -1. So we get minus of 1 by r. So we have fill up that value here directly. You can fill up directly, that is integral of 1 upon r square is a minus of 1 by r. So put all the values of the limit in this and solve, that is 1 upon a minus 1 upon b. This minus minus become plus. Now the capacitance C is given by C is equal to Q by V. Okay, so C is equal to Q upon, put the value of V, that is Q upon 4 pi epsilon 1 upon A minus 1 upon B. So in this case, this Q gets cancelled and we'll get C is equal to 4 pi epsilon upon 1 bracket 1 upon A minus 1 upon B. So this is a capacitance for spherical capacitor. Okay, so in such a type of expressions, we have to simple rule is we have to first mention Q, then we have to mention electric field intensity, find the potential difference V equal to minus B to A, and lastly fill up the values and cancel those terms, those who are cancel those terms, and we'll get last expression. Okay. So next is a isolated spherical capacitor. In previous equation, in the previous equation, that is this equation, B indicates the radius of outer conducting sphere. Consider now that outer sphere is having a radius of infinity. In this case, the inner sphere having radius A is called as a isolated spherical capacitor. Now putting B is equal to infinity. So put the value of B here infinity. We'll get this equation C is equal to 4 pi epsilon 1 upon A minus 1 upon infinity. So 1 upon infinity is a 0. So mention 4 upon is 4 pi epsilon upon 1 by A. So this A goes upper side, we can mention C is equal to 4 pi epsilon A. So this is the expression for isolated spherical capacitor. So you can summarize the capacitance for different for cylindrical, spherical. Okay. So general equation for C is a C is equal to Q by V. Parallel plate capacitor C is given by epsilon 0 epsilon R A by D. For spherical capacitor C is equal to 4 pi epsilon 1 upon A minus 1 upon B. So next, between two concentric sphere, when inner sphere is having permittivity epsilon 2, or the region E is less than R and less than R1, we'll get such a type of expression. We have not expressed this expression. You can at home you can also derive the expression for that is between two concentric spheres. Okay, same methodology apply there, and we will get this type of expression. Easy expression for solving. You can try at home. That is we will get C equal to 4 pi upon 1 upon epsilon 2 bracket close 1 upon A minus 1 upon R1 plus 1 upon epsilon 0 bracket close 1 upon R1. Then next, for isolated spherical capacitor C is equal to 4 pi epsilon A. Capacitor for coaxial cable is given by C is equal to 2 pi epsilon L in P by A. So for coaxial cable or cylindrical capacitor, such coaxial or cylindrical they will ask. So in the our derivation we have mentioned cylindrical capacitor, but they can ask for coaxial cable, same expression for that. Then 2 wire के लिए C is equal to pi epsilon ln S by R. So this is a summary of capacitance, and we'll take one problem on this capacitance. Such a type of a problem is asked in exam. So parallel plate capacitor, as shown in this figure consists of three dielectric layers, that is epsilon R1 is equal to 1, here not mentioned, but epsilon R1 is equal to 1, D1 is equal to the 0 0.4 mm, epsilon R2 is equal to 2, D2 is equal to 0.6 mm, epsilon R3 is equal to 3, D3 is equal to 0.8 m, and S is equal to 20 centimeter square. Find capacitor C. Here, dielectric interfaces are normal to the electrical intensity, and hence we have formula 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So find the values of C1, C2, C3, then put the values in this equation, we will get the capacitance. So first find the value of C1. C1 is a parallel plate capacitor. We can mention epsilon 1 S upon D1, or we can mention it as a epsilon 0 epsilon R1 S upon D1. What is epsilon 0 value? In the previous lecture we have mentioned 8.854 into 10 raised to minus 12. Epsilon R1 is given is a 1 into 20 into 10 raised to minus 4. S is given. Here is a S. S is given. 1 minute. Yes, is given. Yes is equal to 20. Okay, 20 centimeters square we are mentioning this. 20 into 10 raised to minus 4 meter. Okay, so upon D1, what is the value of D1 is a 0.4 mm, that is 0.4 into 10 raised to minus 3. Okay, so we get such a type of value 44.2 picofarad. Then find the value similarly for C2, put the values, that is epsilon 0, then epsilon R2. Epsilon R2 is given as a 2, put the value of ES 20 into 10 raised to minus 4, with the value of D2.6 into 10 raised to minus 3, we get 59 picofarad. Similarly, find the value of C3, put the value of epsilon 0, then put all the values, that is epsilon R3 is a 3 and S is a 20 into 10 raised to minus 4 upon D3. D3, what is the value of D3? 0.8. 0.8 into 10 raised to minus 3. We will get 664 picofarad. Okay. So after solving the values of C1, C2, C3, put these values in this equation. So we have put these values 1 upon C is equal to 1 upon 44.2 picofarad plus 1 upon 59 picofarad plus 1 upon 66.4 picofarad. This is a 66.4 picofarad. So by solving by calculator, we will get the value, that is C is equal to 18.3 picofarad. Okay, so we have find out the value. So similar problems are asked in the exam. This epsilon R1 or D1, D2, D3 values are changed. So keep these formulas in mind. Also solve some problems on cylindrical capacitor, then spherical capacitor. So if you practice, then you can solve in exam. So one of the derivation from this chapter, that is a derived expression for cylindrical or coaxial capacitor, or derived expression for parallel plate capacitor, or derived expression for spherical capacitor. Such a type of any one derivation is asked for 6 to 7 marks. So practice derivations also, so solve problems at home also, and all mathematical treatments. So all treatment you have to solve in your notebook. Okay, thank you. We'll stop here.